In this video, we're going to take a look at how to calculate area between curves. In this first example, it says find the area bounded by y is equal to sine x, y is equal to e to the x is equal to 0, and x is equal to pi over 2. So the first thing that I like to do is to graph it. So I've done that already, and we have 4 lines bounding an area. So the area that we're looking for is here in between all 4 of our curves. And remember, whenever we use a vertical slice to look at this, we're going to do top curve minus bottom curve. So we have y is equal to e to the x being the top curve, y is equal to sine x being the bottom curve, and we're evaluating from 0 to pi over 2. So that's going to be our setup for this problem. We're going to have the integral from 0 to pi over 2, and then we're going to have our top curve, which was e to the x, minus our bottom curve, sine x dx. So this is our area. And now we need to integrate and evaluate this. So we have e to the x, the integral is e to the x, and then when we integrate negative sine x, we get positive cosine x, evaluated from pi over 2 to 0. And now when we evaluate, we get e to the pi over 2 plus cosine of pi over 2 minus e to the 0 plus cosine of 0. And now e to the pi over 2 can't be simplified, not without getting a decimal approximation. Cosine of pi over 2 is 0, minus e to the 0 is 1, and cosine of 0 is 1, so minus 1 plus 1, or minus 2. So our area is e raised to the pi over 2 minus 2, and that's units squared, because it's area. So now in the next example, we have find the area between x is equal to 1 minus y squared and x is equal to y squared minus 1. And when we graph it, we have 2 parabolas, and we need to find our intersection points in this example. The last example, they never intersected, so we didn't need to do this. But in this example, we're going to need to know when to integrate from. And so our area that we're looking for is this middle area, bounded by the 2 curves. And in this example, we're going to be taking horizontal slices to find our area. And when we do that, we're going to do right minus left. So when we integrate this, we're going to have 1 minus y squared minus y squared minus 1. In order to find our intersection points, what we're going to want to do is set the 2 equal to each other. So we have 1 minus y squared is equal to y squared minus 1. I'm going to add y squared to both sides and add 1 to both sides, giving me 2y squared is equal to 2. And then y squared is equal to 1 when we divide both sides by 2. And then y is equal to plus and minus 1. So we know that this is positive 1 and this is negative 1. So we're integrating from negative 1 to 1. So we have area is equal to the integral from negative 1 to 1 of 1 minus y squared minus y squared minus 1 dy, because we're horizontal. And now I'm going to simplify before I integrate and evaluate. So I'm going to combine my constant terms and my y squared terms. So I have negative y squared minus a y squared, or negative 2y squared. And I have 1 minus a negative 1. So I have positive 2 dy. And now I'm going to integrate. So I get negative 2 y cubed divided by 3 plus 2y evaluated from negative 1 to 1. And now when I evaluate, I get negative 2 over 3, because 1 cubed is 1, so negative 2/3, plus 2, minus, now when I have negative 1 cubed, it's still negative 1, so I have positive 2/3, and then I have negative 2. And now when we add this up, we have 2 minus a negative 2, so we have 4. And then we also have negative 2/3 minus 2/3, so minus 4/3. And we end up with 8/3, because 4 can be written as 12/3. 12 minus 4 is 8, so 8/3 units squared. And that's all for this video on area between curves.